Nanoengineer 1. Alpha 9 Tutorial, Small Bearing. In this tutorial, you will model the molecular bearing components, then assemble them to create the final molecular bearing assembly. To model the inner sleeve or shaft, in build mode, select Front View. From the Command Explorer, select Build Atoms. This will bring up the molecular modeling kit. The default atom in the molecular modeling kit is carbon. Notice 3 buttons appear in the molecular modeling kit. These are different possible hybridizations of carbon. During a covalent bond formation, molecules may undergo structural changes in their atomic orbital. This converts the atomic orbital into a new set of orbitals called hybrid orbitals. Nanoengineer 1 supports hybridizations of most common element, such as carbon, oxygen, nitrogen and sulfur. For these elements, you will notice hybridization types in the molecular modeling kit. Below the main group of element buttons, select the sp2 hybridization of carbon, double-click inside the 3D workspace. To deposit carbon, sp2, a pink wireframe will appear around the carbon, sp2, atom. This is a valence error indicator which checks the chemical correctness of the structure. Don't worry about this warning for now. During the transmute operation, at a later stage in the tutorial, these valence errors will be fixed. Highlight a bond point of the deposited C, sp2, and left-click in order to bond another carbon, sp2, to the original atom as shown. In this way, create a 6-member carbon, sp2, ring, by depositing 6 bonded sp2 carbons as shown. Double-click on any atom to select all connected atoms. Select carbon sp3 atomic hybrid in the molecular modeling kit, or hit the 3 key. Select the transmute button. This converts the selected carbon, sp2, atoms to carbon, sp3. Notice that the valence error wireframes around the selected atoms are gone. Select oxygen atoms from the molecular modeling kit. Add 6 oxygen atoms to the bond point of carbon, sp3, atoms, facing the student. The oxygen atoms need to be reoriented. To do this, highlight a bond point of an oxygen. Hold down the left mouse button and drag it to the final position. Reorient the remaining oxygen atoms the same way. They should be pointing towards the center. Select Left View. The part should now be oriented as shown. Click on the Model Tree tab and rename the chunk inner sleeve. Double-click on the chunk name in the model tree in order to rename the chunk. From the model tree, select the chunk inner sleeve. Select Tools, Extrude. The program will enter extrude mode, and 2 more copies will appear in the 3D workspace. From the extrude dashboard, increase the total number of copies to 4 and check the Merge Copies checkbox. Click on the Zoom to Fit button to center the inner sleeve copies. Position the mouse cursor over an atom center of any chunk on the right-hand side of the original chunk. Press the left mouse button and drag the chunk towards the original leftmost chunk until all the bond points of carbon and oxygen atoms are shown in green and blue highlighting respectively. Now click the green check mark button on the extrude dashboard to complete the extrude. Go to Tools, Adjust All. This adjusts the positions of the atoms and bonds to make the geometry of the structure more realistic. Check mark the Autobond option on the Build Atoms dashboard again. Using left mouse drag, select the rightmost oxygen atoms in the 3D workspace. Use the Delete key to delete these atoms. Use the Shift key and region select the oxygen atoms on the left and right-hand side using left mouse drag. Select carbon, sp3, from the molecular modeling kit's Atoms tab. If it's not already selected, click the Transmute button on the Build Atoms dashboard. This transmutes the selected oxygen atoms to carbons. Region select the 2 extreme rows of the carbon atoms. Select Hydrogenate from the Command Explorer to add hydrogen atoms to the bond point of the selected carbon, sp3, atoms. Select Sulfur, sp3, Atoms from the molecular mode linkage. Atoms tab. Highlight a bond point of a carbon atom and click on it. Notice that the sulfur atom added to this carbon also forms a bond with a neighboring carbon atom automatically. This is because the auto-bonding is enabled, checkmarked, from the Build Atoms dashboard. When it is enabled, additional bonds are formed automatically with the deposited atom. If any bond points of neighboring atoms fall within the van der Waals radius, and the deposited atom has extra bond points available. In the next step, you will disable this feature and see what happens. And check the Autobond checkbox under Advanced Options on the Build Atoms dashboard. Highlight a bond point of a carbon atom and click on it. Notice that the deposited sulfur atom forms only one bond, and thus doesn't autobond with the neighboring carbon atom. Rotate the 3D workspace using the middle mouse button. Drag such that the bond point of the sulfur and the neighboring carbon are clearly visible. Highlight the bond point of sulfur and hold down the left mouse button and drag it until the bond point of the nearest carbon atom is shown highlighted. Once it is highlighted, release the mouse button. This forms a bond between the sulfur and the carbon. Locally adjust the atom position of the newly deposited sulfur to remove the bond stretches to some extent. To do this, highlight the atom center and select Adjust Atom S1041 from the context menu. S1041 is just an internal atom ID. The name does not matter. It is likely to be different in your case. The context menu is displayed by pressing the right mouse button. This locally adjusts the atom position, and the bond stretches will be removed. Checkmark the Autobond option on the Build Atoms dashboard again. Highlight a bond point of any carbon atom in the structure. Right-click on it and select Transdeposit from Molecular Mode. Link it. This deposits sulfur atoms to all the remaining bond points as shown in the following figure. Right-click on it and select Transdeposit from Molecular Mode. Link it. This deposits sulfur atoms to all the remaining bond points. Select the chunk from the model tree. Go to Edit, Cut. This transfers the chunk to the clipboard. We will use this part later in the assembly phase.